Let us start with any two sets. First, you need to know, in order to define a relation, first you need to know that Cartesian product. You know what I mean by Cartesian product? A cross B is nothing but a Cartesian product. Means what? Set of all order pairs such that A belongs to A and B belongs to B. Is nothing but what? Cartesian product. Cartesian product of A and B. Right? This is what my first component. This is nothing but what? Second component. So A cross B is nothing but what? Set of all order pairs. That means, for example, you can take A equals to 1, 2. Suppose you can take B equals to AB. What is my A cross B? A cross B is nothing but what? 1 comma A. First element is coming from A, second element is coming from B. So next 1 comma B. Next 2 comma A, 2 comma B. Right? This is nothing but A. This is A. My set B is nothing but what? A comma B. 1 comma A, 1 comma B, 2 comma A, 2 comma B. This is nothing but my A cross B. Right? Now what is meant by relation? So we say that R is a relation. R is the relation from A to B. If and only just it's a subset of A cross B. That's it. If it is a subset of A cross B, automatically that R is a relation from A to B. Right? Suppose, for instance, you take this example. Just continuing this example. My R1 is equals to, my R is equals to, suppose 1A or 2A. Is it a relation from A to B? What is my R? My R is not. This is my A. This 1, 2. This is AB. What is my R? My R is 1 goes to A. Next 2 goes to A. Right? So question is it a relation? Yes, because it is a set of A cross B. Right? Therefore, R is a relation. R is a relation from A to B. Right? Once you define a relation, we say that different types of relations. Suppose you take this R1 is equals to, suppose we can take let X A, Y B. Is it a relation from A to B?
No.
No. Because it's not a subset of A cross B, therefore it's not a relation. Right? So this is nothing but about a relation. Next, we discuss about the types of relations. Before types of relation, first you need to know the number of relations formula, counting formula. Notice the cardinality of A is M, cardinality of B is N. What is the cardinality of A cross B?
M cross N.
M into N. That's it. Cardinality of A into cardinality of B. Right? Now question is number of relations.
Number of relations.
2 power of M.
2 to the power of M into N.
From A to
Power
B.
M.
Mn. Right? So that is nothing but what? 2 into 2 power Mn. That means what? You take any relation, it must be a subset of A cross B. Any relation that you started with. You take any relation that you started from A to B. Right? From A to B, that must be a subset of A cross B. So in order to find a relation, it's enough to find a subset of A cross B, right? In order to find a relation from A to B, it's enough to find a subset of A cross B. So how many subsets of A cross B? There's 2 power Mn, right? Because there's how many elements in A cross B? Number of elements in A cross B is Mn. Therefore, total number of subsets of the set which is containing Mn elements is nothing but what? 2 power Mn. Therefore, number of relations from A to B is nothing but what? 2 power M. Right? That's what actually idea. So to find a relation, it's enough to find a subsets of A cross B. You know, A cross B contains Mn elements. Automatically, that number of subsets which containing Mn elements is nothing but what? 2 power Mn. So this is nothing but cardinality of the relations. Means cardinality of the A cross B and the number of relations from A to B. Right? And let us discuss about types of relations. First is void relation. First one is what? Void relation means empty relation. Means what? Empty set is always a subset of any A cross B, therefore it's a relation from A to B. So empty set is always is nothing but a relation, which we call it as void relation or empty relation. Next is universal relation. Next is what? Universal relation. So what is universal relation? A cross B itself is a universal relation because the total number of order pairs is nothing but what? Is a relation because it's a subset of A cross B. A cross B itself is a subset of A cross B. Therefore, itself is a relation. This relation we call it as a universal relation, which we call it as what? Universal relation from A to B. Right? These are very standard relations. Right? Next is what? Identity relation. What is identity relation? You take any sets?
A cross A.
Yeah, that's it. Not A cross A, set of all order pairs of the form A comma A such that A belongs to A. It's nothing but what? Identity relation.
Identity relation.
Right? A goes to A itself. A goes to A itself. It's nothing but what? A goes to A itself. It's nothing but what? Identity relation. So this is what actually about a number of relations from A to B. Suppose you want to define a relation on a set. Relation on a set. You take any set. What do you mean by relation on a set? Look at A cross A. If any set which is subset of any set which is subset of A cross A, therefore automatically R is a relation on E. R is a relation from A to A. That is same as saying that R is a relation on set A. This is what actually relation on a set. For example, you start with any set, for example, A equals to 1, 2. What is my A cross A? My A cross A is 1, 1, 1, 2, 2, 1, 2, 2. This is nothing but set of all order pairs from A to A. Now take any R, any subset. Take any subset 1, 1, 1, 2. Is always subset of A cross A. Therefore, R is a relation. R is a relation on a set A. Right? Any subset of A cross A is nothing but one relation on a set A. Right? Any subset that you consider from subset of the A cross A is nothing but one relation from A to A, or else relation on a set A. Right? Suppose you take this. Suppose R is equals to on the same set 1, 1. Suppose 2, 3. Is it a relation on a set A?
No, sir.
No, because it's not a subset of A cross A, therefore not a relation on a set A. Right? Next is, so relation on a set, there are so many types of relation on a set, standard relations. So first one is types of relations. What are the types of relations on a set? First one is reflexive relation. What do you mean by reflexive relation? Take a set. What do you mean reflexive? Any set, any element that is related to itself. Any element that is related to itself. If that happens, that is nothing but, if that happens, we say that R is reflexive. Understand? Any element that is related to itself, automatically that relation is nothing but what? What is my R? R is a relation first on a set A. R is a relation on a set A, and any element that is related to itself, automatically one can say that R is reflexive on A. For example, you can take this. A is equals to 1 to same example that you started with. A cross A is nothing but what? 1, 1, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2. For example, I consider this 1, 1, 1, 2. Is it reflexive relation? Is it reflexive relation?
No, sir. 2 to not covered.
Right?
No.
What is my definition? Any element that is related to itself. But for 2 is not related to 2 itself. Therefore, it is not reflexive on a set A. Right? It's not reflexive. Suppose you take this, A is equal to same set. Suppose R is equal to 1, 1, 2, 2. Is it reflexive?
Yes, sir, it is.
Yes, because 1 is related to 1 and 2 is related to 2. Suppose R is equals to 1, 1, 2, 2. Suppose 1, 2. Is it reflexive?
Yes, sir.
Yes. I don't bother about 1, 2. What I bother, just any element that is related to itself or not. If you know this, any element that is related to itself, it's enough to show that, it's enough to say that R is a reflexive on a set A. I don't bother about 1, 2 or 2, 1 something else. What I require, any element that is related to itself or not. If that happens, that is a reflexive relation. Sorry, on a set A. Right? Suppose you take this. So next is counting argument. So before counting, first you need to know that different types of relation. This next is symmetry relation. Symmetric or symmetric relation. What is symmetric?
A relation B, B relation A.
Yeah, A is my set. We take any relation. R is a relation on a set A. Then R is symmetric on a set A if and only if A is related to B for any two elements A comma B belongs to A, automatically B related to A. If that happens, this R is symmetric. Right? If A is related to B, automatically B related to A must be there in R. Example, we take A equals to 1, 2. As I said, what is my A plus A? 1, 1, 1, 2, 2, 1, 2, 2. Right? Suppose R is equals to this 1, 1, 1, 1, 2. Is it symmetric?
No.
No,
Sir.
right?
No.
1 related to 2 is there, but 2 related to 2 now is not related to
1 is not
there. Therefore, it's not symmetric. Suppose if I take this, R is equals to 1, 1. Is it symmetric?
Yes, sir.
Yes, sir.
Yes. Right? Suppose you take 1, 1, 2, 2. Is it symmetric?
Yes,
Yes,
sir.
sir.
Yes. Yes, right?
Yes, sir.
Suppose if you take R is equals to 1, 1, 2, 2, it's 2, 1.
No, not symmetric.
No, sir.
No, right? 2. Automatically, B must be related to A is there. Right? This is what actually symmetric. Right? Next is transitive. Right? To take any set, to take R as a relation and a set A, we say that R is transitive and a set A if and only if A is related to B and B is related to C is there, definitely A must be related to C is there. This is true for any 3 elements. If A related to B is there, B related to C is there, we need to show that A is related to C is there. If A is related to C is there, automatically this is transitive relation. For the same example, I am taking same example because it's for simplicity, for understanding purpose. So 1, 2, 2, 1, and 2, 2 like this, right? Suppose R is equals to, suppose you take this 1, 1, 1, 2. Is it transitive? Yes, right? 1 is related to 1 is there, and 1 is related to 2 is there. and that will imply that 1 is related to 2 also there. Yes or no?
Yes, sir.
Therefore, it is symmetric. Suppose R is equals to 1, 1. Is it transitive? Sorry, is it transitive?
Yes, yes, sir.
Yes.
Right. Right. Suppose you take this. My A set is, suppose you can take natural numbers, right? Suppose R is my relation. R is defined by like this. A is related to B if and only if this A is less than or equals to B. For A comma B belongs to A means natural numbers. What is my A? My A is natural numbers. So question is it reflexive? Is it reflexive?
Yes.
Yes.
No.
Any element that element is always less than or equal to itself, right? Suppose you take 1,
Yes, sir.
it is always less than or equal to 1. Suppose you take 2, 2 is less than or equal to 2, right? So any element that is less than or equal to itself, this is true for every natural number. So whenever A is less than or equal to B, so what is my definition? A must be related to A. This is true for every natural number. Therefore, any element that is related to itself, therefore, R is reflexive on natural numbers. Question is it symmetric?
No, sir.
So if you say no, so give a counter. To provide A is related to B, you need to provide 2 elements in such a way that A related to B, but B is not related to A. I can take A equals to 1, B equals to 2. So automatically 1 is less than or equals to 2. Therefore, 1 is related to 2 itself. Whenever 1 less than or equals to 2, whenever 1 less than or equals to 2, we can write it as A1 is related to 2. But the thing is, 2 cannot be less than or equals to 1. Yes or no? 2 cannot be less than or equals to 1. Therefore, 2 is not related to 1. So therefore, 1 is to 1 related to 2 is there, but 2 is not related to 1. 2 is not related to 1. Therefore, it's not symmetric. Question is it transitive?
Yes, sir.
Give me 3 elements. If you take A is related to B and B is related to C, so A is related to B means what? A less than or equals to B. What is B related to C? B less than or equals to C. Therefore, A must be less than or equals to C. Therefore, A must be related to C is there. Right? So therefore, it is transitive. And I said C. Right? Suppose we take another example. Suppose A is my natural numbers. Right? A is related to B. If only if A divides B. Yeah. First one, is it reflexive?
Yes, sir.
Yes, sir.
You give me 1. If you give me 1, 1 divides automatically 1. So 1 is related to 1 itself. If you give me 2, 2 divides automatically to itself. Therefore, 2 is related to 2 itself. So therefore, any natural number that is related to itself. So it is reflexive. Question is it symmetric?
No, sir.
Suppose 1 A equals to 1 you take, B equals to 2 you can take. Automatically 1 divides 2 is there. So what is meant by 1? A divides 2 B, A divides B is there. But the thing is, unfortunately, 2 does not divide 1. Therefore, 1 divides 2 is there, but 2 does not divide 1. Therefore, A related to B is there, B is not related to A. Therefore, not symmetric.
Metric.
So is it transitive?
Yes, sir. Transitive.
Suppose we take any 2, 3 natural numbers.
Hello, biscuit खाने को देना ना.
A divides B is there. Take B divides C is there.
इडली है दाल लिखा
While
है कौन है?
A divides B is there, B divides C is there. So what is meant by A divides B? So therefore, automatically A divides B there, B divides C is there. Automatically, what is this? B equals to AQ1 for some integer, positive integer. Right? What is meant by B divides C? C is equals to some BQ2 is there for some positive integer. Yeah. So what is this? C is equals to substitute B value in this equation. What do you get? AQ1 into Q2. Therefore, this can be written as A into Q1 Q2. Therefore, C is equals to AQ1 Q2. Therefore, what does it mean by this? A divides C. So therefore, whenever A divides B, B divides C, automatically A divides C by division algorithm. Right? So therefore, it is transitive. Therefore, it is transitive. So it is reflexive, but not anti-symmetry, not symmetry, but it's transitive. Right? Suppose you take this example. Here is my integers. Take any positive integer. Means it's a natural number. A is related to B if and only if M divides A minus B or B minus A. You can take anything. So this is a very important relation in group theory, by which we can define an equivalence relation, equivalence class of that integer, that we call it as what? Equivalence class of 0, equivalence class of 1, by which you can define Zn. You know Zn, class of equivalence classes, set of all equivalence classes. So this is what actually equivalence relation, by which you can define a equivalence relation. So this is what actually important relation. Question is it reflexive?
Yes, sir.
What is my sense? You give me any integer. So this positive integer always divides 0, right? Any positive integer divides 0, right? Yes or no? Yes, right? Any positive integer divides 0.
Yes, sir.
Positive integer divides
Yes,
0.
sir.
But 0 can be written as A. 0 can be written as A minus A. Therefore, A minus M divides A minus A. Therefore, A is related to A by definition. Therefore, it's reflexive because A is related to A. This is true for every A belongs to A. Question is it symmetric? Suppose A related to B is there. What does it mean by this?
Yes, sir.
What do you mean by M divides A minus B? M is equals to Q for some integer. What do I mean by this? To multiply with minus, what do you get? M into minus Q. Whenever Q is integer, minus Q also integer because it's an integral domain. So automatically group, with respect to addition and multiplication, it's an integral domain. Therefore, B minus Q is equals to M into minus Q. Therefore, whenever this happens, whenever something M and M, M divides Q, M divides A minus B means what? This, what do I mean by this? So B divides M divides B minus A. So therefore, M divides B minus A means what? By definition, B related to A. So we start the proof by taking A is related to B. We end up with that, B is related to A. This is true for any two elements that you consider in integers. Right? Therefore, it is symmetric. So what is meant by transitive? This is redundant. This is also redundant. We take A is related to B. B is related to C. Automatically, what does mean by this? M divides A minus B. Similarly, what is this? M divides B minus C. What does mean by this? A minus B equals to M into Q1 for some integer. B minus C is equals to M into Q2 for some integer. Therefore, just you add them these two equations. What do you get? A minus B plus B minus C is equals to M into Q1 plus Q2. But the BB cancel. A minus C is equals to M into Q1 plus Q2. Therefore, A minus Q can be written as some M into some integer. Therefore, M divides A minus C. Whenever this happens, is related to C. So from which all cases, what you observe? It's what it is reflexive, symmetric, and transitive. Right? So if the relation satisfying these three relations, automatically that relation is an equivalence relation.
సార్ ఒకసారి మళ్ళీ పైదాన్ని క్లియర్ గా ఎక్స్ప్లెయిన్ చేయండి సార్ ఫాస్ట్ అయిన త్రీ ప్రాపర్టీస్
Which one?
ప్రాపర్టీస్ ఈక్వాలెన్స్ రిలేషన్స్
Yeah, these three examples, three cases. ఈ త్రీ కేసెస్
యా సార్ కొంచెం తెలుగులో కూడా అప్పుడప్పుడు తెలుగు కూడా వాడండి సార్.
Yes, sir. 3 cases.
సార్ రిఫ్లెక్టివ్ ట్రాన్సిటివ్ ఉన్నాయి కదా సార్, ఆ రిలేషన్స్ అది ప్రాపర్టీస్ ఒక్కసారి అట్లా తెలుగులో కొంచెం చెప్పండి సార్. తెలుగు ఇంగ్లీష్ కంబైన్ గా వాడండి సార్.
ఓకే. See, M అనేది 0 డివైడ్ చేస్తుందా కదా First reflexive అంటే ఏంటి? Reflexive means any element that is related to itself.
పరివర్తనం.
అంటే తెలుగులో
నో సార్, తెలుగు పదాలు కష్టం సార్, తెలుగు వర్డ్స్ వాడొద్దు, బస్ ఎక్స్ప్లెనేషన్ తెలుగు అంతే.
రిలేషన్ అని అంటే చాలు సార్, అవసరం లేదు అంత.
ఏ ఎలిమెంట్ దాంతోనే రిలేటెడ్ వాళ్ళు కంపల్సరీ ఉండాలి. ప్రతి ఎలిమెంట్ కి రిలేషన్ ఉండాలి, దాంతోనే ఉండాలి, వేరే దాంతో అవసరం లేదు. ఉన్నా లేకుండా మనకు సంబంధం లేదు, కానీ ఏ ఎలిమెంట్ అయినా దాంతో కంపల్సరీ రిలేషన్ ఉండాలి. రిలేషన్ అనేది we say that R is equivalence relation.
Sir, will you please give me total definition of this symmetric and transitive and relative? Sir, I think we understood this concept, sir, but total definition we need, sir.
Written already. Go back to your slides.
Yeah, of course.
Right. So therefore, R is reflexive. Right. R is reflexive. What is mean reflexive? Any element that is related to itself. Next is R is symmetric. On A. What do you mean symmetric? A related to B when you consider B must be related to B. Right? By notation. And third one, R is transitive. On A. That means what? Whenever A related to B, B related to C is there, you need to prove that A related to C. This is true for any three elements. If that happens, that means R is equivalence relation means if and only R must be reflexive on A, R must be symmetric on A, R must be transitive on A.